This is A21, Module 4, January 10. Unfortunately, this is from the new spec and I haven't got a blank copy. I've already written the answers in, so I'll just go through them when they're written in here. Figure 5.1 is a planned view of the apparatus used by Geiger and Marsden for the Rutherford scattering experiment to establish evidence for the existence of atomic nuclei. So this is very like quite a small diagram you have in your notes. And this, of course, represents the vacuum or the evacuated tube that the experiment was carried out on. So part A says essential items or requirements of the apparatus are numbered 1 to 6. State which each number indicates in the apparatus. So instead of writing them in just down here where I already have them written in, I'm going to write them just beside it. So number 1 is, of course, your source or your alpha source, where the alpha particles were released from. Number 2 is beam of alpha particles. Number 3 is, of course, the gold foil that the particles hit. Number 4 is a zinc sulfide screen. And then it belongs to number 5, which is a travelling microscope. And number 6 then, it has to be carried out in a vacuum. And those are your 6 points there, your 6 numbers. Part B, state the function of item 4 and describe briefly how it operates. So item 4 is the zinc sulfide screen. And the zinc sulfide screen, what happens is when the alpha particles pass through the gold foil and hit it, they cause excitation of electrons within the material, move up to upper levels. When they come back down to their level again, they give out energy in the form of light. And so they cause what are called scintillations, or light, just wee sparks of light. And they were picked up then by the travelling microscope. So what I've written down here, and I'll just scan in a wee bit so you can see it better. When the alpha particles hit the screen, they cause electron excitation with atoms of zinc sulfide. There'll be a mark for that. When the electrons return to original position, they give out energy in the form of light, and those are called scintillations. Part C. Listed below are 2 of the results obtained from the experiment. In relation to atomic structure, state the conclusion that which may be made from each listed result. Now, these conclusions come up all the time, or the observations come up all the time, and you have to draw the conclusion. So they're really 2 things, and you can get one conclusion out of one of them and then 2 out of the other. And the first one is that most of the alpha particles experience no collisions, and that's an indication that the atom is mostly made up of empty space. The second conclusion, or second observation, very few of the alpha particles, about 1 in 8,000, were deflected almost directly backwards or back scattered. And the conclusion there was that the nucleus is very, very small because only 1 in 8,000 alpha particles were deflected backwards. And so it's very, very small. And the second conclusion is the fact that any were deflected backwards indicates that the nucleus is positively charged. And I would always write in there as it repelled the alpha particles, which are also positive. And that ensures that you're getting your 2 marks there if you make sure that you expand a wee bit on your explanation.